In this video, we will discuss 10 multiple choice questions from the topic electric circuits. Which of the following represents dependence of resistance on temperature? Temperature coefficient of resistance. Resistance of a resistor depends on temperature coefficient of resistance. The other two options, doping concentration and permittivity, have no effect on resistance of a material. So the answer is temperature coefficient of resistance. At parallel resonance, current flow through inductor and capacitor are same. If resistance value of a resistor increases when there is a rise in temperature, then temperature coefficient of the resistive material is positive. So if temperature coefficient of resistive material is positive, then when temperature increases, resistance value also increases. On the other hand, if temperature coefficient is negative, then when temperature increases, resistance decreases. From the following, identify a passive element. None of these. The given options, current source, voltage source, and transistor, all are active elements. Which of the following is purely resistive? 500 E or 500 ohms. 0 plus 500 J is not purely resistive. Similarly, 500 plus 200 J is also not purely resistive. So second option is the correct answer. Q factor of a parallel resonance circuit is also known as current magnification factor. In a circuit, an active element supplies power. Active elements supplies power and passive elements absorbs power. So resistor, capacitor, inductor all are passive elements, while voltage source, current source, etc. are active elements. A circuit which contains neither a voltage nor a current source is known as passive circuit. So a circuit with no source is called as a passive circuit. In electric circuits, a closed path with several branches is also called as loop. The internal resistance of an ideal voltage source is 0. For a voltage source, ideally internal resistance is 0, and for a current source, ideally internal resistance is infinite. Practically for a voltage source, internal resistance is very small, and for a current source, internal resistance is very high. Thanks for watching Circuitszz Analytica. Enjoy learning.